Okay, Algebra 2, I'm home today. Hopefully you can hear the sound better than you did the other day when I was recording. But this is 2-8. We started the other day. I went ahead and erased all the work, so I'm going to go back through the problem rather than pick up right in the middle of the problem and be really confusing. So example 1, you shouldn't have to write a whole lot down until we get to the very end, okay? So systems of equation in 3 variables. We talked about how we do substitution and elimination. We've done that before where we've had just 2 equations. Now we have 3 of them, okay? And it's very, very, very important for you to do all your multiplication right. Make sure you have nice, pretty handwriting when you do it so that you can read everything nicely. So what we're going to go ahead and do is we are going to, they have these designated as like equation 1, equation 2, equation 3, okay? So we're going to kind of refer to them as that, and we're going to go and try to eliminate a variable, okay? So when we look at all 3 of these equations, we say, okay, we have to eliminate, when we add stuff together, we have to eliminate the same variable in all 3 spots, okay? And so I think on Friday, you guys chose to do x, maybe? So we said that if we, let me get my stuff up here, we said that if we multiply this through by -2, into this equation, that will make this guy -4, and he will cancel with the +4, okay? So I'm going to go ahead and do that. That will be -4x. You should already have this written down, so don't have to write anything, just watch. Plus 20y plus 12x, or 12z equals, and that'll be -24, okay? So what I'm going to do is I'm going to add these 2 together, and I'm going to write the answer over here, which is what we did on Friday, okay? So the x's should cancel. The y's, I should have 21y plus 18z. Did I do that right? I'm looking at my work from the work that we had from the other day, and that's not what we got. 21y plus 6z. Oh, that's right, because I'm looking at the wrong problem. This guy right here. Let me fix him. Plus 4z. That's what he should be. Okay, so this is 10z over here. Let me fix him. There we go. I'm trying to plus 10z equals, and then this will be -12. Okay, all right, then I'm going to erase this stuff. Now I have to put together like the second and third equation like this. Okay, so what we said is that we still have to eliminate x. Here we have x and here we have x. We want to make them be 6. Okay, so I would have to take the 2 times 3, and I would have to take the 3 times 2 in order to do that. Okay, we said let's multiply through by a -2 on the bottom so that way he cancels. Okay, so when I distribute 3 times 2, this will be 6x minus 30y, okay, keep going, minus 6z equals, that will be 36, okay? Then, if I multiply the -2 through, it'll be -6x minus 16y minus 38z equals -72, okay? Now I'm going to take these 2 green equations together, and I'm going to put them off to the side over. I'm going to add them together, so the x's will cancel. The y's, I will have -46y. Okay, and then we have -44z. That's what those will become, equals. And that is -44. No, I can't math. That's not 72. That is 76. Okay, so that's -40 when I put that together. Okay, I need you guys helping me, like keep me in check so that I multiply numbers correctly. Okay, because I obviously can't do it by myself. All right, now, we have to decide what variable to eliminate here. So now we're to the point where we've seen this before. 2 equations, 2 variables, really, really super ugly stuff. Okay, and we could try to find like a small number, but we just said, okay, let's eliminate z and let's multiply the top one by 44. And let's multiply the bottom equation by 10 is where we just said, okay? We probably could find a smaller number, but let's just go with that, okay? 44 times 21 we said was 924y, okay? 44 times 10 is 440z, and then 44 times -12 is -528, okay? Now we're gonna do the same thing at the bottom. We're just multiplying through by 10, so -460. Y, you should do this without a calculator, minus 440z equals -400. And that's what he becomes, okay? Now my z's do cancel. If they don't, I did something wrong. And if I add the y's together, I get 464. Y equals, and then this added together is negative 928. Okay, then I divide by 464 and it comes out really nice. And it is negative 2. Perfect. Okay, all right, now, oh, look at all that ugly mess that we have. And it was all kind of like right in one spot. We could have used the work down here, I guess, that they provided for us. They have like a page and a half of work situated out for just this one problem, okay? And we could have followed that, but I just left it right here in close quarters, okay? So we got y equals negative 2. Perfect. Now, we have to go back through and we work like backwards to try to find z and to try to find x. So I'm going to go back up to my previous step, which is this guy right here, these blue ones, and I can plug into either one of those equations that I want to. I'm going to just choose the top one where I have 21y plus 10z equals negative 12. Okay, and I know what y is from down here. Y is negative 2. Okay, I'm going to plug in and I'm going to multiply. So 21 times negative 2 is negative 42. Okay, and then I'm going to add 42 to the other side because I'm solving for z. Add 42, add 42. So I have 10z equals negative 12 plus 42 is 30. And look, that's going to come out nice again. These should mostly come out. Yeah, I think they'll all come out nice with whole numbers, okay? If you get a decimal, then check your work because you probably did something wrong, okay? Z equals 3. Now, the last thing I have to do is solve for x. So I can go back here. So we went back one previous step to find the next variable. Now we can go back to any of these original ones to find x. Okay, I'm just going to go to the top one right here, if you can even see it. It says 4x plus y plus 6z equals 12. Okay, all right, this guy was y and he is negative 2. And this guy is z and he is 3. Okay, and I'm plugging them in there. Again, I could have chosen any one of these three equations to do that. Okay, I just chose the top one. So 4x, negative 2, this guy is 18, right? So negative 2 plus 18, those are on the same side of the equal sign, so I'm just going to combine, plus 16 equals 12, okay? Then I'm going to solve for x, so minus 16, and 4x equals negative 4, and divide by 4, and x is negative 1. I can't write negative 1. There we go. So final answer. Hey, look at that. We are going to write these as, so over here I said write them as an ordered pair, like 1, 7, or something, something. We're going to write this as what's called an ordered triple. So negative 1, negative 2, 3, not comma after the 3. That's what he will look like if I put them in order of x, y, z. Okay. Now that point is still the place where all of them intersect. All of these equations intersect, except when you have three variables, it's like a line that exists in like three-dimensional space, okay? So imagine that there's just a line floating out in space. It has an x and a y and a z coordinate. It's no longer on a flat surface where you just have x and y, right? It has like a third dimension that's like popping out at you, okay? And this dot is going to be in three-dimensional space where they intersect each other, okay? All right, so that's how that works. That was example 1. We've got one more example to do, and then that's it. This one has one solution. The next one's not going to have one solution. It's going to be, like, icky. Well, actually, these ones, when they have infinitely many solutions or no solutions, they're actually easier. So, here we go. Let's see what we're going to do. Eliminate one of the variables. Okay, they went ahead and they eliminated x. I'm going to say, if we have to compare, these are my x's, these are my y's. Y has that negative 20 there. That might be kind of big. And these are z's, okay? I'm going to say the x's might be the easiest ones to reduce to. So let's go ahead and do that, okay? If we're going to combine these top two equations, I would have to just multiply this first one by 4, right? And that would make him negative 4x, and then these two will cancel, right? Okay, so let's just do that. 4 times negative x is negative 4x. 4 times 5y is going to be positive 20y. And then 4 times negative 4z is going to be negative 16z equals 4 times negative 2 is negative 8. Okay? Now, I'm going to combine that one with the middle one. Oh, man. negative 4x and 4x goes away. 20 and negative 20 goes away. Negative 16 and 16 goes away. Okay, so on the left side, we have nothing left, which means we have 0. Okay, but negative 8 and positive 8 goes away. So we have 0. That's kind of odd. 0 equals 0. Hey, that's infinitely many solutions because 0 always equals 0. Well, that's exciting. Do we have to do anything with the third equation then? Because I don't think he's going to do anything really. Let me check and see. Yep, as soon as we don't even have to do anything with the third equation. Oh, step 2, check the third plane. Oh, wait a second. Yeah. Okay. Yeah, we'll go ahead and check the third one. So the first and second one, equations 1 and 2, when we add them together, make 0 equal 0. Okay, we can check the third one. I've never had them cross out on the first try before. That's exciting. Okay, now, what we can do is let's do this. Why don't we eliminate the second and third equation? Let's do that. I don't think that's what they did, but let's do that. So let's multiply this bottom one by 4. 4 is going to go through there. So negative 4x minus 4y minus 4z equals negative 4. Okay, and we have that going on when we distribute those through. Okay, I'm going to add them to this guy right here. So the x's are going to cancel. Okay, the y's, I will have negative 24y plus 12z equals, because that's this right here. And then I have 8 minus 4 is positive 4. Okay, let's see. Let me go down, check. Solve the systems of equations. They added the equations together. So there are an blank number of solutions. You know, I think we could have just stopped after the first one. I don't think we have to check the third plane. We got 0 equals 0. That's infinitely many solutions. I think we're okay. I don't even think we had to do what we just did just now. You can back up. We got infinitely many solutions. We don't even have to check the third plane, I don't think. Okay, so there's that. Now, they did not do an example where you have no solutions. So we have infinitely many solutions. Up here we had 1 solutions. What does it look like when you have no solutions? So let's refresh our brains here. When you have no solutions, you'll have some stuff cancel out. Well, you'll end up with like 0 equals 8 or 4 equals 7. I don't know. You'll end up with 2 things on either side. Your variables will all be gone. So you have no x's or y's or z's left. And you'll end up with stuff that doesn't make sense. Like 0 is not equal to 8. 4 is not equal to 7. Okay. So when that happens, you will end up with no solutions. Okay. Here where 0 equals 0, 0 is always equal to 0. So you have infinitely many solutions. And what that means for infinitely many solutions is that I can plug in, you know, whatever I want in for x, y, and z, and it will come out to be equal to -2. Like I can plug in, you know, different combinations for x, y, and z, and there are a lot of solutions. There are infinitely many solutions that I can have, okay? Not just any number for x, y, and z, but there's an infinite number of combinations that would work for x, y, and z, okay? So that's how that works. You get 0 equals 0, infinitely many, and that's it. I'm gonna skip the story problem. We'll maybe talk through one of those tomorrow, but you guys have 2, 4, 6, and I think maybe that's all I gave you. It's just those problems. Okay, you may need to work on another sheet of paper if you have like a piece of notebook paper to write all your stuff out. But do 2, 4, and 6 and see what you get. I'm not quite sure if you get one of each, like one solution, one no solution, one infinitely many solution. You'll have to look and see. But work on those for the rest of the period, and that's it.